Welcome to our third session on scatter plots and regression. Let me share my screen. All right, and now hopefully you're just going to go through what scatter graphs are, what regression lines look like, a bit of information on that. Then we'll go through some worked examples, and then we'll do some exam-style questions. So if you haven't already, grab a pen and paper and your calculator so you can follow along. And take notes as well as you go. If you have any questions, put them in the chat and I will answer at the end. So we'll also have a Q&A session at the end. Or if I see them during, then I will also try and answer. So if you were not here before, I am Ashley from Miss IB Maths, collaborating with Exam Dojo, and I am an IB teacher, tutor, and IB examiner. So if you're looking for extra support with maths lessons, you can find me on Instagram, Miss IB Maths, or on my website, missibmaths.com. All right, let's get into it with a warm-up question to get into the maths mode. So give an example of bivariate data, meaning it has two variables that we might compare in real life. So any two variables that would make sense to compare in real life. So you could just write A and then two variables, and then B, give an example of two variables that make no sense to compare in real life. And if you see this box at all, like on the previous slide, that means to answer in the chat. Any two variables that we might compare. To give an example, we could say height and age. We could compare people's height and age. That might make sense to compare in real life. Maybe the number of hours you study for a maths test and test scores. So we could take a class and say, how many hours did each of you study for this test? And then each of their test scores and see if there's a correlation, if there's a relationship between those two variables. Temperature and weather. Yeah, good one. All right, any that make no sense to compare in real life. This could be anything, things that don't have an effect. For example, your test scores and your shoe size. That is something that could have a relationship. It probably won't, but they don't make sense. Your shoe size probably has nothing to do with the test score that you get. All right, thank you for your response. Appreciate it. So on that note, things that make no sense to see if they have a relationship between. This is on a website called Spurious Correlations, and they have a whole bunch of bivariate data where there are two things that make absolutely no sense, but they do form a relationship. There's correlation between them. So, for example, associate degrees awarded in mathematics and statistics correlate with Google searches for a dollar store near me. And obviously, there's no relationship between that. So they correlate, but they don't cause each other. So that's a very important distinction. Correlation does not mean causation. Another one, popularity of the mocking SpongeBob meme correlates with liquefied petroleum gas used in Kyrgyzstan. See how they have a very close correlation, but most likely nothing to do with each other. All right, so just make sure that you're never saying that one variable implies another just because they have a correlation. So in a question, they might ask something like that where you have to give a reason why. So it really helps to think of the real life situations. All right, just starting with some definitions. So we're using scatter diagrams. These have different names. So scatter diagram, scatter plot. You could also say scatter graph. Like I've said here, they're all the same thing. And they're involved of the little dots that are not joined with a line. We don't draw them with a line to give us information about two variables. So you take one variable and put it on the x-axis and one variable on the y-axis. So as opposed to frequency, this is not about frequency. This is bivariate. Bi meaning two variables. And each point is plotted as a dot. And then we're going to find patterns between these two variables. So those patterns are form, direction, and strength. So for form, we have two words, linear or nonlinear. So an example of a scatter plot that was linear would look something like this. It's making a line, so we could draw a line through it. Nonlinear would look something like this. It could be dots like this. Although those are making two lines, that's actually following more of a quadratic form. So that would be nonlinear and linear. So those two words. Another nonlinear could be something that has no correlation. Something like that. There's no pattern going on there. That is nonlinear. We can't make it. If I put a line like that or like that or like that, none of them make sense. All right, then we have, let's go through the other ones. Let's do it in green. Direction. Direction is positive, negative, or neither. So it is either going to be going like this, that is a positive. Here going downwards like that, that would be negative. And again, it's all over the place, neither. All right, then we have strength. It is either strong correlation. There's a clear line going on. We say moderate, and weak. And finally, no correlation. So when you get asked to describe the correlation, you need to use one from each of these. So it could be linear, positive, strong, or linear, negative, weak. Any of those combinations. Make sure that when you get asked to describe the correlation, you're using one from each of these. All right. So in this one, if you had to use those three categories, what would you call this? So firstly, would you say it's linear or nonlinear? Well, that is quite clearly linear. That's making a very nice line. So we'd say it is linear. All right, then is it positive, sloping uphill, or negative, sloping downhill? This is uphill, so it is positive. And strength, weak, moderate, strong, no correlation. This is strong. This is very much a straight line forming a very straight relationship. So I would say that is strong. Now, again, these can be quite subjective. Sometimes it's hard to tell between strong and moderate or weak and moderate. And we're going to get to the R value, which is going to give us actual mathematics to be able to look at that. So can you describe the correlation? Either answer yourself now, try and go through it, see what you think, or if you're feeling brave, answer in the chat. Oh, I just saw that you cannot see my screen. Oh dear. Let me stop sharing and try that again. How about now? Can you see it? Ah, great. Sorry about that. And apologies that I didn't see that sooner. That probably made no sense at all. So let me just go back over that again. All right, so here, let's go from there again. Here we have an example of something that correlates that obviously does not have any relationship with each other. So dollar store near me and degrees awarded. So there it is forming a very nice correlation, but obviously no effect on each other. If you want to see more of these various correlations. All right, now this one here as well. Very nice correlation there. See how it spikes like that and then drops down. Very closely correlating, but no relationship between these two variables. All right, so scatter graph, also called a scatter plot or diagram, looks like this with our dots. So on here, we have our x-axis, our one variable, and on our y-axis, we have the other variable. I'm just going to go a little bit faster through this just because you might have heard what I was saying earlier, but if you want me to go slower or go over anything again, let me know. Okay, so we have either linear or nonlinear, positive, negative, or neither, and strong, moderate, weak, or no correlation. So this one would be an example of linear, making a very straight line. Here as well, let's just make those points a little bit more clear. These are following a line, so these would be linear. This is nonlinear. There's no line going on here. No relationship. Then positive, negative, or neither. This one is positive, going uphill, positive. This one is going downhill from the left, negative. And here, neither positive nor negative. So that would be neither. Then strong, moderate, weak, and no correlation. That would look like strong would be following, just use the marker, a very clear line like that. That would be strong. Then moderate would maybe be a bit more like something like that. Just draw all of these ahead. Weak would be less so. It's still following a positive linear shape, but it's a lot weaker. They're not so closely on that straight line. And then no correlation, they're all over the place. There's no pattern that's going on here. That's no correlation. All right, so this one over here, we have, let's take that all the way. Linear, making a very nice line like that we can draw through, excuse my line. It is positive, it's sloping uphill, and it is strong because all of those points are going to be falling on my line if I drew it nice and straight. All right, so now the question that I had, can you describe this correlation with the words linear or nonlinear, positive, negative, and the strength of the correlation? What do you think? Moderate, positive, linear. Yeah, very nice. So definitely, let's go with that one. Definitely linear. Positive, sloping upwards. And I agree, moderate. Yeah, it is not closely on the line, but they are quite near on either side. Nice. Oh, let's write that, moderate. Okay, how about this one? Would that be positive or negative? Weak, moderate, strong, no correlation. Linear or nonlinear? So right now we can see there's no pattern going on here. If I had to draw a line like that, or if I had to draw a line like that, it wouldn't make any sense. So we say this is no correlation. No correlation. Not positive, not negative, not linear, non-linear. But even to say non-linear is assuming there's some kind of shape, but there's no shape. So you could still say non-linear, that's fine, because it's definitely not linear. But for positive or negative, we would say neither. But because nothing is happening here, it's actually okay for these to just say no correlation. So if there's no correlation, it doesn't really make sense for there to be any other relationship. All right, how about this one? If you get a question like this, it's very common to have, for them to ask, usually for 1 or 2 marks, describe the correlation. So when they say describe correlation, that's what I want you to remember. They want these words. And that is in generally easy 1 or 2 marks. Yeah, nice. So that is a line like that. We can draw a line through. That is making sense. So generally, when you're drawing a line through, you should have the same number of dots on the top as on the bottom. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So let's actually, we need a couple more. So it'd be more like, we want as many dots on the line as possible, if possible. So this one's a little bit better. We have even amount on top as on the bottom. So that would be where our line was. So yeah, that is linear. There is some kind of linear relationship there. It is negative indeed. And yeah, this is weak. Very nice. Well done. Okay, so as I was saying, when you don't have a calculator, for example, paper 1 question, you're not going to be able to find the line of best fit on your calculator. So you're going to have to draw it. So just like I drew it now, you need to have the same amount of points on the top as on the bottom. So try and really use your ruler if you have, to kind of count how many are on the top, how many are on the bottom, and adjust it. And try and get as many on the line as possible. So you see there's quite a few here that are on the line. And that really helps you to see as well how strong the correlation is. The line of best fit passes through the mean point. So the mean point is not given on here, but it will be somewhere in the middle, let's say there. That you have to calculate. So to find the mean, we use this notation. You take all of the x values in your table, add them all up, divide by how many there are, and you get your mean point, x bar. Same for y. Take all of the y values, add them up, divide by how many there are, and you get the y mean coordinate. So when you do this by hand, you have to calculate the mean coordinate and then write it. So you can either write exactly what it is, or you can write it just in this notation, x bar, y bar, and that shows that you indicate the mean, where it is. Your line of best fit must go through your mean. So it's a good idea to plot your points first, then plot your mean point once you've calculated it, and then take a ruler and draw a line going through the mean point. So just a question in exam questions, will we have to do this by hand? So in paper 1 of AA, or AA, SL or HL, you won't have access to a calculator. So if you have to draw the line of best fit, then yes, you draw it by hand and plot it yourself. It is unlikely that they will ask that. They may, but unlikely. Mostly it will come up in paper 2, and you will do it with your GDC. In AISL, in AI, you will always have your calculator, so you'll always be able to do it with a calculator. But yeah, very rare. All right, so like I was saying earlier, when we are looking at weak, moderate, strong, sometimes it's quite difficult to say where it is. To be exact, is it moderate, strong? Is it weak, moderate? So we have Pearsons product moment correlation coefficient. So quite a big word there, otherwise known as the PPMCC, Pearsons product moment correlation coefficient. We just refer to it as the R value. So they'll say find the R value or find the Pearsons coefficient. So sometimes just Pearsons coefficient. Just be aware of all of those. Now this is on a scale of -1 to 1. All right, so this is describing using numbers. We love that in maths, using numbers, the correlation. Your calculator is going to give you this value. So there is a formula. You do not need to know it for the exams. You will always find it on your calculator. So at 1, out of the words, what do we think? 1, is that going to be strong? Is that going to be weak? 1 is strong. So -1 you might think is weak, but actually -1 is strong as well. What is weak is 0 in the middle. So think 0 correlation. That is weak. And then on the scale, it can be values like 0.5. That would kind of be our moderate. -0.5. And let's put that weak is more here. And then at 0, no correlation. So the closer to 0 you get, the weaker it is. The closer to 1 you are, or -1, the stronger it is. Remember, this is very important. This is only meaningful for linear relationships. You can't use the PPMCC, the R value, for relationships that aren't linear. It's only for linear relationships. And R equals 0, that means that there is no linear relationship, not necessarily no relationship at all, because if you get R equals 0 for a scatter plot like this, making a quadratic, it could be 0, but there's correlation here, just not a linear one. If you're in the AI course, they might give you a critical value, and you need to determine if a linear model is appropriate. So they'll give you the critical value in the question, and you'll need to take the absolute value, so the positive, basically, of your R value. And if that is bigger than the critical value, if it's above, then it can suggest that a linear model is appropriate. If it's less than the critical value, a linear model is not appropriate. So a question might look like, the critical value is this, this, and this. Determine if a linear model is appropriate. So more than the critical value, and we're good. It's a linear model. If not, then we can't assume a linear model is appropriate. But that's just for AI. All right, so let's have a look at what these R values look like. This is a little bit confusing because it's the other way around. So this is from R equals 1. It's quite small there. Let's do it in green. This is R equals 1. So this is, can you see, a positive strong. On this side, R equals -1. It's downhill, it's going negative. So a negative R value means it has a negative slope. Positive R value means it has a positive slope. So obviously the closer we get to the R value of 0, it is no slope. So here's R equals 0.8, so a little bit less. That's, let's say, between strong and moderate. Say about 0.9 you can say is strong. 0.8 can be described as strong. 0.3 weaker, 0.5 moderate. So here they're getting less and less around. So these two, R equals 0.3 and R equals -0.3, similar graphs, similar spread, but just one is positive and one is negative. All right, that brings us to our regression line. If we have calculators, which for finding the regression line, we'll have calculators. So they're written like this. You might also know them as linear lines, mx plus c. Some people use mx plus b. They're all the same thing. The most important there is that we have a, or m, is our gradient. and BC, or now B is our y-intercept. So our regression line, this is a regression line y on x, because we're with respect to the function y with the variable x. So y comes first, if you can't remember which way around this is, because there's x on y and y on x. We'll look at x on y later. X on y. This is first, so that means it comes first in the formula. So that can be just a helpful way to remember which one is which way around. So we're going to be finding the values of A and the values of B, the gradient and the y-intercept, using our calculator. This is just to help you with the calculators, because yesterday I had some questions about calculators, and I work with the TI Inspire. I have worked with TI 84, but it turned out yesterday in the session I didn't actually remember a lot about the TI 84. So I have this. Just take a picture of this for now. So later on when we do that, depending on your calculator, you can have the instructions. I will be showing you on the TI Inspire, and it's quite similar, but there you go. Just take a picture of that. All right, if you need that at another point, this stream will be available, so you can also come back and have a look at that. Okay, so let's see what that looks like in a worked example. Now, if you have a calculator, I recommend that you go through this and you type in the data and work it out on your calculator as well. It's really good to just get used to which buttons to press, knowing what it looks like, so that you're prepared. Okay, so we have the scores of 8 students for a maths test and an English test. So maths at the top, maths is our x variable, and y is this variable. So is the English. So it's good to think to yourself now, before we even start, well, do we think that maths will have a relationship with English? Do students tend to score similarly in different topics, in different subjects? If you're good at maths, are you good at English? Just start thinking about those kind of questions, because they can help answer questions like this at the bottom. All right, so we want the equation of the regression line y on x. So that's just the standard one, y on x. So what that means is for y equals mx plus c. This is what I use. Feel free to use if you use a and b, or m and b. So I need to find the m and I need to find the c. So I need to type in this data. So if I go to my calculator, I want calculate, no, I want new. So I want lists and spreadsheets. And very important to give a title to each column. So that's going to be my X data, that's going to be my Y data. This is really important when you're doing X on Y later, and just when you're choosing it, it helps you to not be confused. You could even write maths and English if you wanted to make it really clear. So let's go 7, 18, 37, 52, 61, 68, 75, 82. All right, double check your data. So many mistakes that I see in exams are students who have input the wrong data. So 12, 17, 41. Hopefully they don't give you like loads and loads of data. They usually won't for time reasons. Okay, so if you're a good student, you would go and double check this. I'm not going to do it right now because time-wise, but make sure you check it. Okay, so once you've input your data, we're going to go menu, statistics, stat calculations. And we get a whole bunch of things over here. What we're interested in these two, linear regression. Can you see mx plus b and a plus bx? These two are the same, actually. Mx plus b is just the same as a plus bx, but switched around. The variable is still x, right? And they still have a gradient and an intercept, or an intercept and a gradient. If you want to make things easy for yourself, take out the decisions that you have to make, just go for mx plus b. There we go. All right, so our x list, we had already chosen x. That makes sense. Y list, we wanted our Y. Remember, we labeled these. The rest we don't have to fill in. And our results. Remember, my X was in the A column, my Y was in the B column. So I want this to be in the C column in the next one, so it doesn't overwrite my data. Okay, there we go. So it's all come up. We have the title, we're in the form mx plus b. So our m value here, 0.943. So that's 0.944. M equals 0.944. Remember, 3 significant figures, we always want that, 944. Our B is minus 18.05, so that'll be minus 18.1. Double check that you have the same. If you don't, maybe you typed it in wrong, maybe I did. Minus 18.1, there we go. So you see our M and our B and those values. So they're not going to give it to you like in this way. They're not going to give it all done. You have to take the M value and the B value and then put it together in the equation. So what are we going to get? For our line Y on X, we're going to have Y equals M. So that was 0.944 X plus C, or in that case, B. All the same thing, just different ways of writing it. Remember that gradient is always attached to X. Then minus 18.1, that was our B, our y-intercept. All right, and there we have it. That is our Y on X equation. So if this was a scatter plot that we were plotting, it would come up with a line when we have a line of regression through there. The gradient is positive, so it's going to be a positive increase. So that means as our math scores get higher, our English scores also get higher. That makes sense. So then that was our A. B, use your equation. This is a very common second question. You find your equation, then you use your equation. To estimate, remember we're estimating because we've just taken a line that sort of goes through those points. To estimate the English score for a student who scored 45 in maths. So 45 in maths, just to remember that maths was X. So we want to know when X equals 45, what is Y? What is the English score? So let's substitute X in. 0.944, put in 45. This is easy enough. Just be careful when we do the X on Y, you're going to see sometimes you're going to substitute a different X or a different Y, but we'll get there. And if we put that in our calculator, we will get a value. So we want calculate. Oh. No, never mind. Anyway, that was all from yesterday. 0.944 times 45 minus 18.1. Just double check, yeah. 24.38. 24.38. So rounding that off, 24.4. So we would expect that a student who got 45 marks in a maths exam would get 24.4 in an English exam. Then comment on the reliability of your estimate. So there's a couple of ways that you can do this. In this one, we want to look at if the data is reliable. So we're going to be looking at things like extrapolation and interpolation. Extrapolation. This is looking at extra data, data that is outside of our ranges here. And interpolation is looking within the data. Interpolation is way more reliable. So, reliable. The student that had 45 marks, is that within our range of data? Yeah, 45 would be around here. That is inside the data. The result of 24.4 is also somewhere inside the data. So there we can make quite a reliable estimate because we know it's within. If we were asking something outside of the data, like a math student got 99, for example, that would maybe not be such a reliable estimate because that is outside of our data. And sometimes we can use it because you might think, well, if their math score keeps going up, their English score is probably going to follow the same pattern. But there's certain variables in which we can't just keep going forever. I mean, the amount of like the temperature of a cup of tea outside, it's not going to get colder and colder and colder to freezing in a room temperature environment. But if we extrapolate, it might say that we get to the tea being like negative 50 degrees Celsius. But that in the real world situation is not possible. So we've just got to be careful with if we're extrapolating data. Interpolating, generally fine. All right, so we would say, yes, the data is reliable. The answer is reliable because we have interpolated, or the value of x is within the range of x values. Okay, how about the other one, the regression line x on y? So instead of it being, let's write it over here, y on x, that's the one we just did, where it was y equals, let's put it in terms of a as well. Well, let's do it like that, mx plus b. We now have x on y, so x is the subject instead of y. Now we can't just rearrange our formula here to make y the subject. It doesn't work like that. These are different lines. Even though it's the same data, they're going to be different lines. That comes down to least squares, least squares regression. And I won't go into that now because it's not important for your exam, but just remember, don't rearrange them to get the other one. One is not the inverse of the other. So this we get in a different way, and luckily there is just one change, and you do that on your calculator. But same thing, that is our y-intercept. And this b here attached to the variable, the y, is our gradient. So just so a question, is everything you are covering in these sessions for all maths courses? So is some content you are talking about only for AA? This is for everything. So, sorry. A lot of talking. What I'm covering is meant to be that AI and AA can both learn from it with statistics and probabilities very similar. The only difference is that HL often covers more in both, but I'm covering what all 4 courses are covering. So this will be in both exams. If there is something that is only AI or only AA, I will say that. For example, the critical values, that's only for AI, or graphing a line of best fit was only AA. But otherwise, this is all for both courses. Okay, regression line, x on y. So we're just going to swap x and y on our GDC. You'll see how that looks in a second. I will show you. Very important note, because questions often are going to ask something like this. The y on x and x on y both intersect at the mean point. So that is something they have in common. Their mean value, remember that x bar, y bar, is the mean point. They will both intersect. So it might look something like this. Your y on x line is like this, and your x on y is like that, and they will both intersect at your mean. So a question might ask you, they say, find y on x, find x on y. Which point, they won't give you this hint that they intersect at the mean point, but they'll say, which point, or these two intersect at a point, what is that point? And you will find the mean value yourself. On the calculator, it's usually given. You can calculate it as well. So let's have a look at an example. I didn't even need to draw it. There's a better one. So that's our x on y line, our y on x line, and our mean point over there. Okay. This is a lot of data, so let's go and put that in. We have the heights, x, and the mass, y, of 10 students. So find the equation of the regression line y on x, find the equation of the regression line x on y, and then we're going to answer some questions about it. So if you have a calculator with you, maybe take a picture of this, because I'll be going between to put it in, but take a picture and put it on your calculator. It's good to practice. The more fluent you are with your calculator, the better time you're going to have in your exam. And that comes down to just even typing points in. So let's go calculate. We want new document. Nope. Lists and spreadsheets. All right, so let's again remember label X, label Y. Very important. 155, 158, 162, 165, 173, 176, 180, 180, and what was it, 85. Then 50, 52, 55. $72, $78. Oh, that's already one key that you have gotten it wrong. 50, 52, 55, 58. 62. 65, 68, 72, 78. 85. No one's noticed what my mistake was. Let's check again. 158, 162, 65, 68. There we go. So that's a big clue that something in my data went wrong. All right, there we go. So let's go find the equation line. So we go menu, statistics, stat calculations, and we want linear regression. So we're finding M and B. We want X and we want Y. And our results, let's put it in C. All right, there we get it. So we have M is 1.19. So for this one, 1819. 3 significant figures. And B was minus 136. Once you have this line, you can use these values to find your X values. So it's okay to round at this point. All right, there we have it. For the regression line X on Y. Okay, so now this is when we do something different. So instead of having my X's be X's, my Y's be Y's, I'm going to switch them. And this just happens on the calculator. So I have everything here, all of my data. I don't need to change anything. What I am going to change is when I go to menu and put in my variables. So we do all of the same things, go linear regression. That maybe went a little bit fast. Let me just do that again. Menu, statistics, all good things happen at menu, stat calculations, and we want linear regression. So far, exactly the same. Now, this is the key. When I do my X list, I'm going to put in Y. Okay, we're switching. This is the only difference in our actual calculation. So X becomes Y and Y becomes X. So we've just switched it for the calculator. The calculator doesn't know better. First result column, I'm going to put it in C again. So I'm going to override the data that's already there. Also, just so I don't get confused. So I'm going to press OK. It may overwrite data. That's fine. I don't need the other data. All right, so now we can see we get the new value. So M is 0.832. So remember writing X now. And 0.832. And, oh, see, I'm just so used to writing x. I should write y. Y. And our b is 115.5. So to three significant figures, that'll be 116 plus 116. Okay, and those are some quite different graphs there. So here we're taking x, we're finding x. So we can input a value of y, a mass, and we can get a height out of this. We can't do that on this one. So this one is giving me y. So I can only put in x's. I know with normal equations, you can put in y and rearrange to find an x. In this, you cannot do that. So if I get an x value, my height, I can only get mass from this equation, okay? For this one, then I can do it. If I want to know mass from, if I want to know height from mass. So here I can put in my, this was my mass. Oh, sorry, yeah. I can put in mass and I can get out height. It usually doesn't work that way around. So make sure that's why our x on y is helpful. So here I can put in height, because that was my x, and I can get out mass. So this will be very useful, and I recommend setting it up like this with your variables, so you know in the questions which one you're going to put in. Any questions? No. Okay, so a student has a mass of 60 kgs. So let's look at where we're going to input mass. Mass of 60 kgs. If I want to input mass, well, it's not this one. It's not my y on x, because that's inputting height to get mass. If I want to input that, I'm going to need to use my x on y. So if I put in mass, I'm going to get x equals 0.832 in brackets 60 plus 116. All right, I'll put that in a calculator, and out will come my height. The height, if I have a mass of 60 kgs, what will my height be? And which regression line you used? Well, that was my x on y. X came first, x on y. All right, another one. A student has a height of 172. Okay, so my input is height. So which one inputs height? Well, this one, my y on x. So I would substitute into this one, y equals 1.19, x being 172, minus 136, input that on my calculator, and I would get the mass that a student of 172 would be. So this is why y on x and x on y is important. So if you write out your variables like this here, mass, height, your input, your output, that really helps to make your questions really clear. And for this one, we use the y on x. If anything is unclear, just let me know. But hopefully that makes sense. All right, we're going to look at some exam style questions now. And if you see any of these questions, like linear regression, finding y on x or x on y, you can be really happy, because they're nice questions. They involve the calculator a lot, and there's not many different ways that they can ask these questions. So if you've done 5 exam style questions, you've pretty much covered everything that they could possibly ask you. In other questions, they bring in all different kinds of things like calculus and differentiation and whatever. But for this topic, it's pretty much, it's always going to follow the same sort of style and be the same kind of questions. Okay, the following table shows the marks scored by 7 students on 2 different mathematics tests. Okay, so our variables are going to be 2 different tests. Test 1 is x, test 2 is y. Let L1 be the regression line of x on y. Really, really important that you make sure you've got that right. And I would recommend writing it x on y. So that means x equals my plus b. So x is first. Remember, x is first, so x is first. That is L1. Okay, then the equation of the line L1 can be written in the form, yeah, there we go, x equals ay plus b. Same thing, remember? Same thing. So here they've been really nice. They've actually hinted at the fact that it's going to be in that form. They won't always do that. Find the value of a and the value of b. So the value of A, let's write it how they've written it. X equals A, Y, B. It's a good idea to not get confused. A is the gradient. So when I'm looking, because this is where it gets confusing on your calculator, because your calculator is not using A, it's using M. So A is gradient, B is intercept. Just really important that you don't get these mixed up. We'll see in the mark scheme, it's important that you say A equals and B equals, and that those are correct and not the wrong way around. Otherwise, you won't get full marks. So let's go and put those on a calculator. Sorry, it's a lot of inputting data on a calculator. New document. Nope. Listen, spreadsheets. Remember, we call it X and we call it Y. Nothing changes if you're doing an X on Y or Y on X. You're still going to take your X values and put them in, your Y values and put them in. So X, we have 15, 23. Okay, I do this better now. 24. Oh, already 25. 30, 34. Another 34. And 40. Then 20, 26, 27, 32, 35. 37. Oh, interesting. Do you see how it was increasing? Increasing here, and then it went down again to 35. Interesting. All right, now we've got our data. So we're interested in X on Y. So what does that mean? We're going to switch our X and Y's in our stat calculations. So my X list is going to be my Y list. X on Y, we're switching them up. Y is going to be X. And my results column, D is fine, but let's just go C. All right, there we go. So M is 1.29, which was our A. That was our gradient. Ooh. So M, let's go with A. Our gradient was 1.29. Our B is the same, minus 10.37, so minus 10.4. So they just said find the value of A and find the value of B. So they don't say put it together on the line, don't put it all together in an equation. Just say A equals 1.29, B equals minus 10.4. Those are the only important things that you need to have, but do not get them the wrong way around. Okay, be very careful with that. So let's see what the mark scheme says. A equals 1.29 and B equals minus 10.4. So one answer mark for each of those. Only 2 marks, so no method is involved. Remember that you don't need to say, I use my GDC or I press these buttons. You don't need that. Do you see a question? Why did you multiply the A times the Y value in the Y on X regression line in the question before? I shouldn't have, so if I did that, that is wrong. Yeah, the A, so the A times the Y value, that is here, I presume you mean. This was my A times my Y value. That is because I'm using my X on Y. So I didn't do it on my Y on X, I did it in my X on Y because we're wanting to know, remember Y is my mass. So I input the mass times my Y to give me my X. But in this one, I was given an X value. Height was my X. So when I want to find the X value here, when I input my height, I want to get out the mass. Does that answer your question? In the next one, the formula is different. I can write that again. Nope. So in By next one, do you mean this one? By next one in this formula. This was x equals my plus c. So that's different from the y on x. Y on x was y equals mx plus c, because our input is x. Here our input is y. So it's the same formula, just x and y are switched. So really they're the same thing, but we're remembering that we're switching our variables here. So whichever one, it doesn't really matter if it's called m or a. Here they're calling it a plus by. That's the same as saying by plus a. We usually put the gradient times the variable first plus so these are the same thing. Just switch the other way. Whatever is attached to your variable of y or x is always your gradient. So whether I call that m or a, or if I switch it or write it the other way around, it's all the same. Just whichever one is attached to your variable is your gradient, and the one being added or subtracted is your intercept. Nice, good, I'm glad. There's a lot of x's and y's going on. It's quite confusing. So again, I recommend writing what variable. So in this one, height was our input, y was our output. In the x on y, it's the other way around. Now y is our input and x is our output. So you can think about that in your function machine. What are you putting in? And something is happening, and what are you getting out? So in this one, we were putting in height, and we got out mass. That was for our y on x. That's the standard one that follows when we get a question. The top one is usually the x. Then for x on y, we were putting in y, and out was coming x. So it's the other way around. And so now we put in mass, and we got out height. Okay. Now let L2 be the regression line of y on x. The lines L1 and L2 pass through the same point with coordinates PQ. Okay, does anyone remember what that meant? What points do they pass through that's the same? Close, very close. Another word that starts with M. The mean, good. So they pass through the same point. Ooh. Let's go in blue. So the same point with coordinates PQ. So that is our mean point, but now they're calling it P and Q. So P is my x coordinate, x mean coordinate, and Q is my y mean coordinate. All right, so they're asking for that. So how can we find that? Luckily, we're just going to do it for us. So, did we have? No, we don't have our L2. So let's find our L2. In fact, we don't even need to find our L2. They're not asking for it. But we know that they are both going to have the same mean. So L2, L1, and L2 are both going to have the same mean coordinate. So we don't actually need to find L2 because they're not asking for it. They're asking what is the mean. So if we just find the mean of L1, we have the mean of both of them because it's the same point. So L1 was our regression line, x on y. So we can go and find the mean of that. So let's go to menu, statistics, stat calculations, and we want two variable stats. Okay, our x list was actually our y. Remember, it's the other way around. Y list was x because we are still looking at the x on y. I could have done the other way around as well because it's the same data. So that's fine. Doesn't matter here. We can even check. First result column, I'm just going to get rid of all my data there so it doesn't confuse me and override it. So in two variable statistics, Okay, look at that. My X mean is 30.28 with the bar. 30.2, so 30.3 equals, remember it was P and Q. So P was X, which means 30.3. And Q, that was my Y. Let's go and scroll down. It'll be there. First, they do all the X values, and then they do the Y values. There we go. That was two variable statistics because I have two variables. So my Y bar, that was 28.7. And they've just said find the value of P and Q. They haven't said what are the coordinates. If they said what's the coordinate, write it in coordinate notation. Here it can be a P equals and a Q equals. All right, and that was 3 marks. So let's take a look at what that was for the mark scheme. All right, you get 1 mark, method mark, just for recognizing. You didn't even do any maths, recognizing that both lines pass through the mean point. So that recognition could be you saying X bar is this and Y bar is that. If you have any of this kind of notation, that shows you recognize that it's the mean. Or you can say mean of P equals this and mean of Q equals this, something like that, anything that indicates. So again, this is where all the possible working that you could show or thinking is really important. So many marks for recognizing, for attempting in the mark scheme, and then 1 mark each for these. All right. It has been an hour, but I'm going to do one more exam style question. Although I do want to leave some time for questions. Let me ask you, would you like to go through one more exam style question, or would you prefer to ask your own questions? Or have you just had enough for one Sunday morning? Also understandable. Yes, okay, I will take that to be enough. All right, so we're missing the data. That did not copy correctly. Okay, let's go here. Yeah, this was a good question. This is a similar way of using what you know to ask it in a slightly different way. So we have a bivariate data set. Thank goodness it's a really nice and small one. We have our X values and our Y values, and can you see there's P and Q missing over here? So that's going to be something that we're going to have to find. And look, there we go. Over there, we have to find it. They have given us the regression line Y on X. Okay, so we've taken the values of X and they are giving us Y from this one. The regression line passes through the mean point, X bar, Y bar. Nothing new or fancy there. Given that the mean of X equals 7, verify that the mean of Y equals 16. Okay, so they've given us an X value and we need to verify a Y value. Luckily, they've given us the equation already. And remember that our X mean point and our Y mean point lie on this line. That was one of the requirements, that our X mean, Y mean go through this. So all we have to do is substitute. So I'm going to just write that over here. Y equals 2.1875x plus 0.6875. And we need to substitute 7. X equals 7. 2.1875. 7 plus 0.6875. Thank you very much, IB, for all the decimal places. When they say verify and they give something, you cannot use this in the question. This is very important. If they say verify that and they give you an answer or show that, you are not allowed to use the answer they give you in the question. Let that sink in. If you do, you are assuming that it is correct. You can't assume that it's correct. You have to pretend, oh, I don't know what the answer is, so I'm going to use all the other information to find it out, and then I'm going to go bam, y mean is 16. I end with that, and that's how I've shown. But until that time, I cannot use that piece of information. Got to pretend like you don't know it. It's great because you can verify if you're correct or not, but you can't use it. So we've used that piece of information that x is 7. So let's go and put that in. My goodness, this can take ages. Did I want to save? No, that was the previous question. Add calculator. All right, 2.1875 times 7, because we are inputting 7 plus 0.6875. Look at that, 16. So this step here, showing that you're inputting it, how many marks is that worth? Only 1, that's generous. Your mark will not be for this y mean equals 16. They will not give you a mark for that. The mark will be for this. Okay, that's an all show that questions will verify. The answer that they give will not be part of your mark. Now, given that q minus p equals 3, find the value of p and the value of q. Okay, so where were p and q? P and q were here. Let's just write in what information I have. I know that that is that, and I know that, because they haven't given us much in this question. I need to find p and q. P and q are relating to my y. So I have one relationship, q minus p equals 3. So that's one equation. And what could be another relationship I could find here to make another equation? Because if I have two variables, I need two equations. So what could another equation be? Any ideas? What equation could I make out of what I've been given? A little hint here is this. All right, think about the mean formula. How do I get the mean? I add up all of these values. I add them all up. I add them all and I divide them by how many there are. 1, 2, 3, 4, 5. That is an equation for the mean and it's equal to 16. So let me write that there. So we have 9 plus 13 plus p plus q plus 21, all divided by 5 is equal to 16. All right, so now I have my second equation. So let's go and have a look at what that simplifies to. Let's clean up this equation a little bit. So let's see, we have, I'm going to do 21 plus 9 because that's nice and easy. That's 30 plus 13, that is 43. 43 plus p plus q over 5 equals 16. Let's get rid of that 5 and multiply it on this side. So we have 43 plus p plus q. Looking simpler already. 16 times 5, well, 10 times 5 is 50, and 6 times 5 is 30, so that is 80. If at any point here you're not sure what I'm talking about, how do we know it equates to 16? Well, because they told us here that the y mean was 16, and we just proved it in A. So we're using that fact. So we proved here, let me just write that that was our A, and now we're doing B. So they gave us that piece of information, and they gave us in the previous question that the mean was 16. So we know that that's our important information. So we can make a relationship out of, it's like clues for a puzzle that we have to kind of put together. All right, already that's much simpler. I can make this even simpler. I can do P plus Q equals 80 minus 43. So P plus Q equals minus, that will be 37. Double check, that's 70 and 10. Perfect. So P plus Q equals 37. Okay, that was all just to simplify our first one. So I'm going to write these two, my one and my second one. Let's go in black just so I'm not confusing you. Let's write them again. Q minus P equals 3 let's write that as Q equals 3 plus P, just in terms of one variable. So that's the first equation. It's going to make life easier. And P plus Q equals 37. Okay, so this is a set of simultaneous equations. We can use elimination method, we can use substitution method. But now we have those two and we're going to solve them for P and Q. If you have two variables, you need two equations. All right, I'm going to substitute Q. Q is 3 plus P in place of this Q. So I only have P's. So that's going to be P plus Q. Well, not Q. I'm now going to use 3 plus P. Put that in brackets just in case there was a negative. Luckily, there's not. Is equal to 37. So all I've done is just taken that Q, which is 3 plus P, and I've put it in over here. Simplify. P plus P is 2P. 3 plus 2P equals 37. Minus 3 from this side. So 2P is 37 minus 3, which is 34. So P equals 17. All right. Are we done yet? No, we needed Q as well. So we can find Q from any one of these two equations. Both will give us the same answer. So they said P plus Q is 37. Well, P is 17. 17 plus what gives us 37? Nice and easy. So Q equals 20. Q is 37 minus 17, which is 20. Okay. And now we have gotten our P and our Q. So that is another way that the question could ask something, using the fact that you know the mean point is on this line, and using relationships between them, because that Q minus P equals 3, when you first look at that, you might think, what does that even have to do with this situation? Where did P and Q come from? Okay, well, we didn't get them in the table. And how do we know that Q minus P equals 3? Well, that's just they're giving us one relationship, and we need to find another based on the information that we're given, which is this over here. So that was 4 marks. That's quite a lot of marks. Even if you're not sure how to set up the situation or how to solve it, just try and make some relationships. Try and write something down. You often get marks for attempting. So let's see the mark scheme. All right, there we had our substitution. Then you could either have for that substitution, like I said, or when you do 2.1875 times 7 and you immediately go to that, that's also fine. So either that or either that. AG in the mark scheme means answer given. So the answer was given in the exam question, so there's no marks to be gotten there. But you should say it. You should say, therefore, the mean of y is 16. All right, for our one of 4 marks. So this is attempt to use the average. This just means the sum of all the y. Okay, it looks scary, but that just means sum of all the y. It's just adding up all the y values. Sum, Greek letter for sum. Sum of all the y values divided by how many there were equal to 16. We use that to form a linear equation. Then solving it, so just attempt to use the mean. That was your first mark. Then you get A1 for getting your equation. So we ended up with P plus Q equals 37, or you could have the earlier working stages before we simplified, or the whole thing before we simplified it all. Either one of these will give you an A1 mark, which is like an answer mark. Then again, this lovely word attempt. So this is why I want you to attempt every question. Never leave a question blank, even if you have no idea what to do. Rather be wrong than have nothing at all. So attempt, lovely. You tried to solve a simultaneous equation, 1 mark. And then finally, you just got 1 mark for P and Q. So that's not very friendly, but anyway, there's a lot of method marks to be won. Okay. I will stop there. If you want access to these exam questions and these notes from this session, you can just message me on Instagram, search Miss IB Maths, or contact me via my website, missivymaths.com, and I can send you all of these with the rest of the exam questions. I'll put the table back on that original question, and all of the mark schemes are there for you to go through. If you have any questions, feel free to reach out. Common mistakes and exam tips. Remember, interpolation is more reliable than extrapolation. So look, are you finding a value that's inside the data? That's okay. If it's way outside the data, probably not a good idea. Remember not to rearrange y on x or x on y. You need to find them separately. They're two different lines. And then it always helps in these to think logically about the real life situation. Like, would this make sense? Think about what you're saying it when you're saying it, especially in the reasoning. If anything was unclear, Exam Dojo has fantastic notes on all the topics in Learn. So you go and click Learn, and then you click the topic that we're on. So today we did linear regression, here, Pearsons, scatter diagrams, Pearsons, linear regression, and X on Y down here. So there's all those notes, all these examples I went through. You'll find beautiful notes there. Also with exam tips. And then obviously there's the question bank and practice questions. There'll be a homework assignment for this session called Session 3, Scatter Graphs and Regression. The class codes to join these classes, they're called this, are on the info page that I sent at the beginning. So it's on the chat. If you go all the way to the top of the chat, you'll find the info page that has past session links, upcoming sessions, and all information about the class codes. Right. Well done for following through with that, especially if you're here from the beginning. I know it's a lot on a Sunday, and hopefully you learned something new or something you didn't know before, and that it helped. So any questions you have? You're welcome. Anything at all. Ah, that's so lovely. You're so welcome. Appreciate it. Just going to wait a little bit longer in case someone is typing out a long question. Or in case you need some time to think of a question. All right, I'm going to assume that no one has any more questions. So like I said, feel free to reach out if you think of something, or if you want these lesson notes. And yes, did you answer my question from yesterday at the beginning? That was the question about the left, the center, and the right of the TI-84, I think. Just tell me if that wasn't the question, but I think that was the question that I promised I would answer in this session, which was yes. Okay, so left, this is just from yesterday. We had a session on normal distribution. On the TI-84 calculator, it has a little bit of difference. Left, center, or spelled differently if you're in America, and right. So this just meant that if you're finding the probability of x is less than a certain value, let's say 5, then you need to say left, because if we're looking at our curve, with our mean, let's say 5 is there. X is less than 5, that is, we're wanting to know values to the left, okay? Then if it was P is, say 5, x 10, say 10 is here. We're wanting values in the center. So let me use some colors. This one for green. So this was all the values to the left. So we say we've got to tell the calculator, because it's not very intelligent, actually. They need some help. So we need to say we're looking for data to the left of the curve. Then center was in the middle of 5 and 10. So you're telling it, I want the data that's here in this red part. And if you are running out of colors, let's get another color. Let's go with, I don't know, purple. Data to the right would be everything here. So that's quite nice, because remember I said that the TI Inspire can't do this. It's not clever enough to know what's happening to the right. It only calculates everything to the left. But you're lucky with the TI-84. This is why I think the TI-84 is the best, most user-friendly calculator. It can do to the right. So if P of X is more than 10, so everything to the right of 10, we're going that way, it can calculate for you. So that's very useful. So you just have to tell it. So you need to make sure that you know, do I want everything to the left of that value? Again, the drawing, it helps. To the left, great. So I put left. If I want this range of values, I want center. And if I want this way, I want right. So that was that. Does that make sense? And it works the same with the inverse norm, just whether you're finding it on the left, the center, or the right with what you're given, which is nice. It does make life a bit easier. Okay, I hope that answered your question. Right, thank you so much for joining. Well done, and have a lovely rest of your day. The later session today is on conditional probability. So all the links you'll find on the info page, and we'll be going through common difficult probability questions. See you then. There we go. Bye.